Okay, 8. Divide with whole and mixed numbers. Yes, we're skipping 8, 7. 1, 8, 8. Last official division lesson, only 2 of them. That's it. So divide the fractions, we covered that. Today we'll cover whole numbers and mixed numbers, how that works. And then on to tomorrow, we kind of kick up the difficulty the rest of the way. PEMDAS, repeating decimal type situations with fractions that we're going to have. So gets a little more exciting. I'm just going to start right up here, number 3. And we'll kind of go through the process here. So 9 divided by 3/7. And this one, I guess, is pretty straightforward here. But we know with any whole numbers, what's our move here? Right, always put them over 1. That way we get them. We do that to get them in fraction form. And we do that so it's easy to cross simplify. Of course, we never actually divide. So the first number doesn't change. That 9 is still 9 over 1. It's always the second number. Our division becomes multiply, and then whatever's next door is the thing we need the reciprocal of. You need the reciprocal of 3/7. 7 over 3. Cross simplify away. So 9 divided by 3/7 is 21. Pretty simple. Look at number 7. 5/6 divided by 10. So this one differs from the first, I guess, 4. They got all 4 of these in the sense that now our whole number is sitting in our right spot here. So that shouldn't change anything with how we're viewing this problem, at least to start with here. Just like always when we're working with fractions, we want to make our whole numbers over 1. And now, same deal, we need to rewrite as a multiply. The first value doesn't change, we multiply, but what is the reciprocal of 10? Well, once we put it over 1, it's very easy to see. The numerator and denominator just switch spots, multiplying by 1/10. So same deal, still took the reciprocal, top number goes down, bottom number goes up, convert. Solve as we have any others here. Looks like we get 1/12 is our final answer for that one here. So still putting them over 1, still multiplying by the reciprocal. Nothing really changes here, getting them in that fraction form, finding the reciprocal. Let's look at number 11. 32 divided by 1 1/7. So, a couple things we got to consider first. When I'm working with these mixed numbers, especially over here in dividing, it makes sense to just rewrite the division problem with improper fractions. Because I know I kind of cut us off yesterday on our reciprocal talk, but taking a step back, obviously we talked about whole numbers. If I say what's the reciprocal of 32, you would say? 1 over 32, right, because all my whole numbers, I just put them over 1, and then it's easy to see what my numerator is. It's 1. If I say 24, what's the reciprocal? Right, 1 over 24, and so forth there, put them all over 1. So when we're dealing with mixed numbers here, like if I say what is the reciprocal of 2 2/3? Well, to find the reciprocal of 2 2/3, what you need to do is you need to convert it to an improper fraction first. So 3 2/3, 3 times 2 is 6, plus 2 is 8. 3 2/3 is the same thing as 8/3. Now it should be easy to find the reciprocal of 2 2/3. What is it? 3/8. Right. The reciprocal of 2 2/3 is 3/8. So the only way you're going to get that is by converting this to an improper fraction first. Just looking at this and eyeballing it and thinking you'll just get the 3/8, probably not the best move here. But convert these, and same deal here. We're going to want to rewrite this as a division problem with an improper fraction. Once it's in that form, and I can see exactly what I need to get the reciprocal from in that fraction form, then we can just solve as we have any other multiplying problem. So for here, first thing I'd want to do is, again, I'm calling it 32/1, and I am going to write it as a multiply. Yes, I am. But before I do that, I want to find the reciprocal first, so I know what I'm multiplying by. So dividing by 7 times 1 is 7, plus 1 is 8. I am dividing by 8/7. I'm dividing by 1 1/7. Right? So now I can go ahead and write the multiply problem once I have them both in the form that I want. So the first one doesn't change. The reciprocal of 1 1/7, or the reciprocal of 8/7 is 7/8. So basically I started there. There was my initial problem I had. This is where I should ultimately be ending up here, what I'm solving here. And I had this little middle stop here where I just converted this to an improper fraction, and then go ahead and do the multiply. But you have to do it in that order. You have to get the improper fraction first. You have to convert your mixed numbers to improper fractions first. And then if you can do that, the rest of this should be pretty easy, I would think, straightforward, if you can incorporate that move into your repertoire here. Try on our own here. I'll walk through them, but try 15 and 19. See what you can do with them. I'll walk through them, and then we'll give you some to try. So 15, 2 1/3 divided by 1/6. 5 2/3 divided by 1 1/3. I'll walk through these two, but see what you can do with them.
15 and 19.
Right.
Oh.
Finishing off the row there. Or I guess I should say column. On your own, for how you solve them, again, you may do things a little bit faster and shorter than I'm just kind of showing. If you're not all the way there, not feeling all the way good, kind of the step-by-step process I take to get there. But if you're seeing a lot of this stuff, understanding some of it a little better, I get it. You may have a shortened down, condensed tree of how you solve your problem. That's cool. I'm not saying you have to do all this work, but ultimately, it's all about the right answer in math. If you're getting the right answer, I love how you solved it. So whatever that process is for all of you individually may differ from one to the next. Okay, so here we go, 15. So whenever I see mixed numbers, first thing I'm thinking, multiply, divide, doesn't matter. I want to get them in improper fraction form. Before I do any order of operation work, I need to convert. This is pregame work here we're doing. So 3 times 2 is 6, plus 1 is 7, 7/3. Multiply by the reciprocal, easy to see, 6/1. Cross simplify, final answer, 14. Number 19, this time I see two mixed numbers. And again, same deal. First thing I'm going to want to do is I'm going to want to rewrite both of them in improper fraction form. 3 times 5 is 15, plus 2 is 17/3. And again, I'm going to leave it as division for the moment. until I find what my improper fraction equivalent is of this here. Then I'll rewrite it as multiplying by that reciprocal. 3 times 1 is 3, plus 1 is 4. Dividing by 4/3. Now that I got both numbers in the form that I want, now I'm able to easily convert it to a multiply problem. 17/3 times, multiply by the reciprocal, 3/4. Simplify, 17/4, convert to mixed number form, 4 1/4. Come up with there. Okay. Feel all right about that?
Yeah.
Okay. All right, let's do, here we go, give you your row. Number 5. 27 divided by 3/5. Number 9. 11 twelfths divided by 22.
7, 12.
Number 13. 26 divided by 3.5. 17. 5 1/4 divided by 11/16. And 21. 4 4/5 divided by 1 1/5.
Number 26. 26. Oh.
So these 5.
Oh, wow. Oh. It's 26 times 2. 6, 7. 2/7. Remember, it's 7. Yes, because the reciprocal. Oh. See? So, the reciprocal is 2/7. Yeah. So Oh, that's Cohen's number. Oh. Oh, cool. What? What one are you on now? Not really. What am I doing? I don't know, baby. That's one now. Okay. See this piece of paper? No. That's the point. It's magic. See this piece of paper? No. Exactly. I made it disappear. No. You know, you just say no for no. Yeah. See this piece of paper? No. But you're looking at it. No. 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 Should I say yes? No.
Boys, it's good. There's other people still working. All right. Number 5, Jackson.
Okay. So how it is, we set the problem 27 over 1 times 5 over 3 because we use reciprocal.
Yep.
And then cross simplify. 3 turns into a 1 and 27 turns into a 9. So then you get 45 over 1, which equals 45.
Yep. Just like that. Good stuff. Number 9, Brooke.
9.
Yep.
So first, I put the 22 over a 1, and then I turned that into a reciprocal 122 times 11 12.
Yep.
And then I cross out the 11 and turn it into a 1 and turn the 22 into a 2. And then 1 times 1, 1, and then 12 times 2 is 24, so 124.
That's it. Just like that. Good. 13. Damien's not here. Evangeline.
Okay, so first I put 1 under the 26, and then I rewrote that and turned it into 26 over 1 times 2 sevenths.
Right, so 3 times 2 is 6, plus 1 is 7, divided by 7 over 2. And then as a multiply, reciprocal of 7 over 2 is 2 over 7.
Okay, and then I turned the 2 into a 1, and then the 26 into a 13.
Hold on. Getting close to sending possibly you out of here. Just look this way, okay? Leave them alone. You can play your games later. Okay, one more time.
Okay, and then I turned the 2 into a 1, and the 26 into a 13.
That's not a cross simplify I can make there, because there's no cross here. So basically, this is as simple as this is going to get here.
Okay, and then
So I'm ready to multiply the numerators and then the denominators.
I get 52 over 7.
Yep.
And then that turns into 7 and 3 sevenths.
3 sevenths. There
I
it
wrote
is.
it wrong. I did 36
Oh, 36 over 1. Well, then you would have, what, 72, 10 and 2 sevenths. Right. But, yep, good. So, okay, 17, Sierra.
Okay, so I made it into a fraction, so 5 times 4 would be 20, and then plus 1, so it would be 21 over 4.
Yep.
And then you do the reciprocal, so that would be times 16 over 11.
Yep.
And then that would equal 8. You would cross simplify, and then the 4 would turn into a 1, and 16 would be a 4. And then it turns into 84 over 11. And then that equals 7 and 7 11.
Right. 7 and 7 elevenths. This is what we come up with there. Good. Yeah, real good. Sig 21.
Okay. So you got 4 times 5 is 20, and add the 4, so 24 fifths.
Yep.
Then 5 times 1 is 5, plus 1 is 6 fifths. But then you gotta do the reciprocal.
Yep.
So it's 24 fifths and 5 sixths.
Yep.
And then you can cross out the 5 and make it a 1. And then 6 goes into 24 4 times. And then 6 is a 1. And then 4 times 1 is 4. And 1 times 1 is 1. So it's 4.
There we go. Good stuff there. Okay, last two and then we're done. Try 28 and 29.
I got you.
Right, 2 word problems. 28 and 29 there.
Ooh, spicy.
Beat per hour?
Ooh, that's spicy.
rate of 22.5 feet per hour, how long will it take an insect to walk 90 feet?
And that's 20. After driving 20, 49. Three steps out of 2. How long was it? How many miles would it drive? Oh, that was kind of like those word problems.
Oh, no, yeah.
Yep, 29. After driving 240 miles, 3/5 of the trip was done.
Yeah, let's see this.
So how long was the total trip? And then how many miles left do they have to go?
I know. Okay. So 28 and 30?
28 and 29.
Oh, no. 48. Wow. 48. Wow. This sucks. 48.5.
I want to do 29.
It's the same exact answer.
Jackson, you want 29?
No.
Or said they wanted it?
Me.
Oh, okay, you can have 29. Dom.
Let's go.
29 for Dom.
Let's go.
Okay.
So 28 just as a, I mean, if you're not sure what you're doing here, you could use the simpler numbers concept. If I said at a rate of, say, 5 feet per hour, if I said at a rate of 5 feet per hour, how long would it take an insect to walk 10 feet? If it goes 5 feet per hour,
Yeah.
how long would it take to go 10 feet?
2 hours.
2 hours. And how'd you get it?
2 times 5.
You don't know 2 though. I told you 5 and 10 are numbers. Rate of 5 feet per hour, how long would it take to walk 10 feet? 2 hours is correct. But how'd you get 2?
10 divided by 5.
Right. I took the total divided by the rate there. So you can think about it that way. Well, if it's 5 feet per hour, 10 feet, 2 hours, well, how did I solve that? Well, I took this and I divided it by that. So if you're not sure how to set this up, think about it with numbers that are a little easier that you're like, oh, the answer's 2. It's so obvious. And now that you know the answer, think about it and go, okay, well, how did I get 2? Oh, I took this number and I divided it by that number. So that can help you like set up this problem if you're not certain like which way, what you're, what am I doing here?
Okay.
It's the simpler number strategy where sometimes you just rewrite numbers with really simple numbers, not the real problem, but then you give yourself a super simple problem to do in your head, and then you just go back and think, well, how did I get that answer? And then whatever that format was, in this case 10 divided by 5, just apply the same concept to 90 divided by 22.5. Right? So, right on there. So I guess 28 should get it there. 90 divided by 22.5. 90 over 1 divided by 45 over 2. 90 over 1 times 2, a 1, a 2. It's going to take that little creature 4 hours to walk 90 feet. And again, 22.5, 1 hour. 45 at hour 2. 67.5 at hour 3. 90 at hour 4. 22.5 plus 22.5 plus 22.5 plus 22.5 4 times. There's your 90 feet. So, all right, the last one here. Let's see how he does it. 29, Dom. What are you thinking? What are you seeing here?
I don't know if I said it out the right way, but I think I got it right.
Okay.
Okay. I did 240 over 1 times 5 over 3.
Right, this is a division problem. Essentially, we're dividing the amount because it's not a full trip. I mean, if it was one, the whole trip was done, we would have went 240 miles, but we didn't go. There's more to go. So whatever you should get here, you should be recognizing that 3/5 is less than one. We have now completed the trip. My final answer for total better be bigger than 240 miles. If you get an answer less than 240, how does that make sense? Doesn't. So it is correct. We are essentially dividing how much of the trip has been completed into what we have done. So here it is, 240 divided by 3/5. Of course, we'll rewrite, cross simplify, a 1 and an 80.
And then 80 times 5 is 400.
Right, so how long was the total trip? 400 miles was the total trip.
But then you have to subtract that from 240.
Yes.
And then you get 160, and that's how much miles are left.
That is correct. So to figure out how much is left to drive, you need to know how much of total there is. And then to figure out the total, you have to solve this division problem. So, I mean, you did everything perfect. And that is well done. To see all that stuff there, but 240 divided by 3/5 is 400 miles. That's the total distance. How far did we go? 240 miles. How much is left to drive? Well, we have 400 to go. We've driven 240. 400 minus 240, 160 miles to go. You guys are ready to go to the library, aren't you?